today we'll be discussing some system design concepts. So before going through the system design concepts, let's discuss like why do we need it. So what happened is like you have your application. You created your application. Suppose you have created a Spring Boot application in your system. You have connected with your database, which is also in your system. Now, when you run the application, you can use it through your browser, and you can run all the functionality in it. Now, what you want? You want your application to be used by your friends, your family, your community, and your countrymen and everybody around you. So you hosted it in the internet. So once you host it to the internet, what happens? The number of requests coming to your system increases. The number of data coming to your system is increases. The more and more it is growing, the more and more functionality and the features you have to include. So as soon as the system is comes over the internet, the people are using it. It should have there are the things that the system can handle. Now it should not be like the system break immediately once you launch it into the internet. So these are the situations where the people has already faced it. So we have some concepts like if you are going to grow your application over the internet, or you want to scale your application, you want to launch your application, which is going to handle a large amount of data or a large amount of the users. So you need to understand these concepts. Okay, so let's go to the first concept of the system design is scalability. Okay, so what is scalability? So as I said, once you launch your application over the internet, multiple people are using it, multiple issues will arise. Why? Because there will be more number of users which is going to use it. Other problem. Okay, more number of users, it will be having more data will be having since more data will be there, then we'll have the more feature, more complexity. So more complexities will be there in your application. And once you have all settled down and then you want to expand your application to other geographies also. So that will also comes into the picture. Okay, so this is about the scalability. So uh, you know that the system is once you launch it, so these are the problems that you are going to face because any system that goes over the internet will definitely be having a lot of complexities coming in comes with it. Okay, so now the point is how to tackle it, how to handle these scenarios. Okay, so I'm just telling you high level things like these are the approaches that if somebody asks you to scale your system, so what are the approaches? What are the things you should consider it? Because these approaches you can't apply in every scenario, but you can think based on the situation. For example, first approach is vertical scaling. What do you mean by vertical scaling? Vertical scaling is adding more power to your system. So it means like you are increasing the size of your system. Suppose there is a SQL database, so you are increasing the database size. You are adding more RAM to your system. You are adding more, like you are adding more power to your application. So this is vertical scaling. So next you can say this is the one concept. Sorry. Other one is horizontal scaling. Horizontal scaling means you are adding more servers or a machine to your system. Okay. So it means that like suppose you have no SQL databases or you have the servers. So you can add more servers to run your application so that a load balancer will come into the picture and distribute the data to that service. So the third concept is load balancer only. Load balancer, what it does is it distributes the incoming traffic to different servers. Okay, this is the third concept that we need to take care of while while we have this scalability thing. Okay, so fourth concept is caching. Okay, so why do we need caching? Because we can store frequently access data to reduce the server load. Okay. Then after this, we do have CDNs. Like, why do we need caching? Like, if the system increase, so CDN will be the part of caching only, where we are storing the data, like static data near to your user, or like suppose CDNs is used like if you are Indian and you want Indian content to be at particular region. Like in India, there are multiple states. So for the particular state-wise content you want, the user can access more easily, like so to reduce the latency and everything. So you put particular regional data to that particular CDN so that the user which is accessing from that particular location will access it with less time. So we have the CDNs to store the static assets near to user. Okay. Then we have sharding and partition. So these are the concepts. These are the high level concepts. I'm not going to, we will discuss that later, but I just want you, like, you should know about these things. Sharding and partitioning means, sharding and partitioning, like, sharding is a kind of partition. So we'll discuss later in while we are learning this partitioning. So here what we are doing is we will split the data across multiple nodes in server. Then we have async communication. So you have, if you have, suppose, if you have a part of like in your application, you don't want like the application should wait for some particular functionality, suppose notification thing or the emailing thing. We don't want like the application to stop and wait for the response, like the email is sent to the users to notify some functionality. So we do the async communication so that our application work as it is, and the side by side we can like non-priority item can continue to work as it is without non-priority items. Like we can say that the non-priority items should work side by side alongside with alongside with main task. Okay, so that it saves a lot of time. Okay, then we do have a multi-region deployment. What do you mean by multi-region deployments? It says that like we are deploying to multiple regions. It's not like the deployment is done in multiple data centers, again, to reduce latency and improve redundancy. Okay. And the second last is auto scaling, like what do you mean by auto scaling? Auto scaling means like your active active servers adjust themselves based on the like this. And the last one is very simple. Like it should be the first one, but I forgot to take this initially. So we should work on the microservice architecture. Why? Every like our application will be divided into independent, small independent applications, small independent services that can be, you can say that can be scaled independently. So if suppose you have if you have an e-com application, so in that case, what happens is like the user will see like order service management, payment services, uh, this one checkout services. So these are the items, and these are these microservices which are actually have their own system. They are working on their system independently, and they are scaling it and decreasing it. Like suppose at some particular time, so suppose in a sales time, like checkout team will have a lot of burden. But what will happen if the user is not doing the payment? So checkout team has to scale their system up, but payments team does not have to have, because people are not converting their checkout item to the payment, going through till payment. So these are the one scenario. It's a hypothetical scenario, and I guess it's wrong also. So it's fine. Yeah. So these are the things that we need to consider for handling the scalability of a system. So yeah. So this is the first concept. Okay. If you want to learn more, so I'll share you the links of these concepts. Like you can read out